Hey guys, exciting things are happening. We're graphing linear inequalities. Okay, the good news is if you've been graphing lines, which I'm assuming you probably have, this is not going to be too tricky for you, okay? There's just three things we need to remember that are a little different than graphing lines. And guess what? I'm going to tell you what they are right now, okay? When we are graphing linear inequalities, the things we need to remember is a solid versus a dotted line, shading, and then we flip the sign if we multiply or divide by a negative. Okay, now if you're like, that makes no sense to me, guess what? I'm going to show you. Okay, so stick around. All right, the first thing we want to do here is we want to be in what we call slope-intercept form, which is when y is by itself. That's the easiest way to graph a line. Okay, so I'm going to get y alone first. Okay, and this is where I need to pay attention to this guy right here. If I multiply or divide by a negative, little alarm bells need to go off in my head, okay? Let's go ahead and do this. So y alone, I need to get rid of this negative 5x, okay? So I'm going to add 5x to both sides, okay? Those go away, and I'm left with 10y is less than, I'm going to write the x first, 5x plus 50, okay? Trying to get rid of, well, not really getting rid of, we just want y alone, right? So to get rid of that 10, those are being multiplied. So I'm going to divide by 10. And then I'm dividing this side by 10. Now, if you're like, wait, you did 2 10s. I could have written one big line and written 1 10, but I'm going to end up doing the same thing, splitting it between both of them, okay? All right, so when I do that, I didn't have any alarm bells go off because I divided, but not by a negative, okay? If you want to see an example where I do divide by a negative, I will link one in the corner, but we don't have to worry about this now, okay? All right, when I simplify this down further, I end up with y is less than, we've got 5 over 10, which if we divide 5 into both of those, we end up with 1 over 2x, right? So 1/2 x plus 50 divided by 10 gives me 5. Okay, so here we go. This is the inequality that I am going to graph now. Okay, so for a second, we're just going to pretend it's an equal sign, okay? We're just going to graph it like we graph a line. If you need a review on that, I will link one in the corner, okay? So this is my y-intercept, right? And this is my slope, okay? So I start with my y-intercept. Here's my y-axis. I'm going to go up to 5, right? And then my slope is 1/2. So I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. And I can also go down 1 left 2, right? Okay. All right, now is where I need to look at this guy, solid versus a dotted line, okay? So when I'm graphing inequalities, if I have less than or greater than, I'm going to do a dotted line, okay? In that case, the line is acting as a boundary, but no answers actually lie along that line, okay? If we have less than or equal to or greater than or equal to, it is a solid line, and answers lie along the line as well, okay? So in this case, we have y is less than, so it's going to be a dotted line, which I already kind of have a dotted line, right? But I'm going to kind of make it a little more filled in, okay? So it's going to look something like that. Now, if I had $1 for every time I like drew the line and then I had to go back and like erase because I forgot it was supposed to be at a dotted line, I'd have a few dollars, okay? So try to remember, if you don't, go ahead and like try and erase it, make it look like a dotted line, okay? All right, so there's my dotted line. Last thing I need to do is my shading, okay? So because this is an inequality, I have a lot of answers to this, okay? It's either going to be all the ordered pairs, I guess you could say above the line, or all the ordered pairs below the line, okay? How do we figure out which side it is? We are going to plug in a point. Okay, you can plug in any point as long as it's not along this line, okay? Any point. We like to make it easy on ourselves if we can, right? Don't work harder than you have to. So we like to plug in 0, 0 just because it's easier. If you can't plug in 0, 0 because your line goes through 0, 0, I'll link a video for you in the corner where I do an example like that, okay? So 0, 0, here we go. We are plugging this guy in. You can plug it into this one or this one. it doesn't really matter. Okay, I'm just going to plug it into this one. So we're going to have 0 is less than 1/2 times x, which is 0. As you do this more and more, you'll probably just be able to do this part in your head, but we're writing it out, okay? So then I've got 0 is less than, this goes to just 0, right? 5. Then this is where I ask myself, is 0 less than 5? Yes, it is, right? 0 is less than 5, which means, here's my line. The point I plugged in was right here, 0, 0, and it came out true. So that means any ordered pair on this side of my line is going to work for this equation. Oh, no, it's not an equation. Oh my gosh, inequality. For this inequality, okay? So I shade in, if you can really call this shading. It kind of looks like shading, right? Any answer over here. And it's kind of hard to picture because this line really goes on forever, right? And it's anything over here. So I could really shade this entire paper and onto the rest of the world, right? But we just signify it by shading that much, okay? Now, if this had come out not true, okay, if it had been 0 is greater than 5, which is not true, you shade the side that does not contain 0, 0, okay, or whatever point you plugged in. Okay, hopefully this made sense. If you have any questions, leave them in the comments. If this video helped you, if you could hit like, that would be awesome. I'll also link a playlist for you if you need any other examples, okay? Hope this helped. Thanks. Bye.